right, question number 4 on 2018, we have an ellipse with vertices at 2, -3, and 2, 5. That probably means that our major axis is going to follow right along that x equals 2. And then contains the points -1, 1, and 5, 1 on the minor axis. So the minor axis must be at y equals 1. And these are the points we don't call vertices that are on the shorter side of the ellipse, but they still are an important part of its dimension. So let's go ahead and sketch this, although I guess you're actually doing that as part of 4C, but I would jump in and do that next, just because for me personally, having a visual image of it really helps. Alright, so let's take our points. 2, -3, so +2. Maybe I shouldn't make them spacing that big. Probably can go almost that big. But. So let's go 2 down 3. And then 2 up 5. So I can see here that my vertices go from -3 to +5. So that's a total distance of 8, right? So that means that our middle, the center of our ellipse, has to be halfway between those numbers. So halfway between would be the average of -3 and 5. So -3 plus 5 is 2, and half of 2 is 1. So the average would be there at 1. So there's a distance of 4 here, right? So a equals 4. And then there would be a distance of 4 here as well. Right. So then our other dimension would be at -1, 1 here, and +5. So 1, 2, 3, 4, 5. So there's the minor axis. So that tells us, if we go from -1 to 2 and then 2 to 5, that our b value in here is 3. Right? Okay, so we just follow the formula, which is on your formula sheet. So x minus h squared over a squared. Oh, I just messed something up. Technically, based on the formula we're using, this horizontally is always a, and vertically is always b. I forgot because the previous textbook I used always had, I don't know why I went back to that one all of a sudden, always used a as the vertices and b as the other dimension. So I just started thinking that way. But what we've been doing with this textbook is using a to represent horizontal and b for vertical. So I'll go back to that. And so that would be over b squared. So there's our formula from our formula sheet. So we found a, which is the distance of these points on the minor axis from the center. And we found b, which is the distance from the center to the vertices. And then we have the center right here, which is hk, right, at +2, 1. So it's going to be x minus 2 squared over 3 squared. Plus, and it's plus rather than minus because it's an ellipse, not a hyperbola. So then we go y minus 1 squared for the other value from the center. And that's going to be over the vertical distance from the center squared, so 4 squared. So that gives us x minus 2 squared over 9 plus y minus 1 squared over 16. So there's our equation, which matches the answer key that's in front of me here. Okay, what is the center? Part B, we already found that. To write our equation, our center was at 2, 1. And then graph the ellipse, labeling its center and vertices along the major and minor axis with their coordinates. So technically, to get credit for that last part on that graph, you have to follow all the instructions. Now, of course, this was a final exam that was given on paper, not digitally, which probably makes a bit of a difference. But anytime they tell you to do something on a final, you better do it or you're gonna miss points. So it says to actually label the points. So that's why you can see that there in your answer key that those points have been clearly labeled. No, because you're not actually sketching anything out. It's all being answered digitally. So yeah. It's a different year this year. Anyway, there, it's all labeled. I center it 2, 1. Ta-da! Okay, questions?